Hi everybody, so we're here at Manston RAF Museum in their nighttime war recreation because, well, basically I live a spit away from this place. Now, Manston started in 1916 and closed up in 1999, so during the time when Hitler was trying to put his hand on the knee of England, Manston was here to protect the virtue of this country. But since then, of course, it has closed, it's become a museum, and there's such a lot to learn from visiting any museum. Now, the museum itself is mostly an aircraft museum. But of course, aircraft, well, they're the height of engineering. And some of the engineering here, it's beautiful to see. And this is the kind of beautiful engineering that I'm on about. It's a General Electric J79 turbojet engine. It had about 30 million hours of flight time on its book, and it ceased production only in 2020. And to me, it truly is a thing of beauty, such smooth, sweet, sexy curves. It's probably the closest thing that we can get to in terms of perfection when it comes to the quality and the build of this engineering. That's the thing, isn't it? And this is one of those things that bothers me, that idea of perfection. We have in our heads one thing, and that thing is the perfect idea. A weld, it should be like a stack of coins, and it should all be like a stack of coins, and if it's not, it's rubbish. And if it is, it's perfection. This weld line here, this weld line is on the most perfect engine, the most controlled, the most beautiful, with the greatest technical expertise, and that weld line represents the best we're going to get. That is perfection. But if you look at it, that's not a stack of coins. Look, there's little bubbles here, 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 little blobs that have been ground off, and this is some of the best welding in the world. Now, don't get me wrong, I'm not saying that's a bad weld. What I'm saying is that is a beautiful weld, and it certainly is. But what I'm also saying is that in our head, we have an idea of what perfection is, and then we do it and see the reality of it. When we see the reality of it and it doesn't match what the perfection is, well, we get disappointed. And by looking at what is a perfect weld, what really is a perfect weld, instead of what everybody tells you is a perfect weld, it should give you an idea of how good your work is, because perfection isn't the same thing as exact. What I'm saying here is that don't be upset when your work isn't the same as perfect work, because there's a difference between the world we dream it to be and the world as it really is. If your work is good enough, then don't fix what ain't broke. I made these previous mechanisms in earlier videos. This one's actually a mechanical rectifier, because it doesn't matter which way you turn that, this one turns in the right direction. This one is for raising a weight with the wind, storing it and letting it drop. And the question isn't, are they perfect? It's, are they good enough for what we want to do with them? This is made out of PLA, I believe, and there are better materials if you want to do another job. What I want to do, of course, is talk about concepts and explore ideas, in which case PLA is good enough. The engineering here isn't brilliant, it's got a couple of millimeters tolerance, but for what I want to do, it's good enough. And this one, can this do anything? Is it good enough for a job? Well, yes. So that is an ordinary street light. It's Kent County Council. According to their website, they've got 12,300 of them. They range between sort of 5 meters and 12 meters in height, and the energy they use, because they're all now LED, is somewhere around about 30 to 60 watts, depending on the street light. So could we run that with a wind turbine and a weight as its energy source? Street lights turn on at dusk, off at dawn, and they turn them off between midnight and 5:30 in the morning. So they need roughly 195 watt hours on average to run them. Turns out 195, this is watt hours, not kilowatt hours, it's tiny. Turns out 195 watt hours is something like 702,000 joules, around about there. If we can drag a weight up that lamppost, inside that lamppost, could we store that amount of energy? Well, yes, we could. If the lamppost is 5 meters high and that weight is 14 kilos, it will do exactly that job. So, big question, how big is 14 kilos? Well, if that 14 kilos is a lump of steel, 24 centimeters in diameter, which is the diameter of that lamppost, it would have to be something around about 12 centimeters high, which is that high and that round. That's not a massive amount of steel that we'd have to put in there. So could something like that do that? Well, yes is the answer. If that was running, pulled up that piece of steel, it would store enough energy to run that street light. Is it a perfect answer? No. Will it do the job, and is it good enough? Yes, and that's the whole point. Good enough is in reality perfection. So that idea of good enough is perfection isn't a new idea. Engineers have a word for it. It's called tolerance. Tolerance can be too tight, as the developers of the M16 found out. They made the tolerances too tight, and when they took it into the field, it didn't work. It jammed up with dirt and heat. So tolerance is essential in engineering, as well as basically so many other things. The tighter your tolerance, the more expensive it's going to be. So what you're aiming for, it's never absolute perfection. What you're aiming for is good enough. And it turns out in engineering terms, good enough is perfection. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.